Platinum exists on the periodic table in a particular position nearby gold and silver and other precious metals. It's important to pay attention to the groupings that these things form, because it also tells you what other metals will closely alloy with platinum, and therefore what kinds of minerals you tend to find it with. So zoom in on the platinum properties in brief and talk about that. It was named platina, or little silver in Spanish. They basically considered it kind of a term of derision. They didn't really value it. They found it when they came to the New World in South America. And the Colombians had artifacts made out of platinum. Those artifacts were taken to Europe, and it took many years to really recognize their value, I think centuries, before there was even tested sufficiently. We'll talk a bit about that in a minute. So this is the periodic table that I was talking about. And you see the red box. The red box represents the platinum group. This is a bunch of elements on the periodic table that have chemically similar behavior and tend to intermix pretty readily and be found together quite often in ratios such that it's almost impossible to find pure osmium or pure platinum. They will tend to be found mixed together, or iridium and pure platinum. So have that in mind when you're looking at platinum, which is the green box. And so it's important as you go through that to consider that. Now take a look on the side here. You'll see right next door is our good friend AU, or gold. And just above that, AG, silver. Just above that is CU, or nickel. And next door is, nickel, CU is copper, and next door is Ni, or nickel, cobalt, iron, etc. All of these elements, these metals, tend to intermix to a higher degree the closer they are to each other. Therefore, it's not uncommon to find iridium mixing with platinum, and to some degree, gold and platinum mixes. Now, platinum itself is fairly inert, and so it tends to oxidize much less than other metals, and tends to deteriorate due to acids and things like that in the environment less than other metals. And that's an important characteristic that both led to its discovery and value, and also helps us understand what we're looking for and also why it might be of value. So platinum, the element, is important. This is where it's located on the periodic table. Its license plate is right down there, number 78, and we'll get into a zoom-in picture of that in a second here. So let's look at a comparison. Some platinum nuggets and gold nuggets side by side. Platinum. What makes it so special? Here you can see some of its most remarkable attributes. Its density, you can't see that, but basically it has a density or specific gravity of 21 or thereabouts, and pure gold is about 19 or thereabouts. So it's more dense than gold. Now osmium is even more dense than that, but as I mentioned, rarely will you find any of these in pure form. So you're going to find them somewhat less than what they're qualified at on the periodic table. And in specific gravity tests, because we're talking 100% pure material, 99.9997% pure. So take a look at the color difference here. The gold tends to look very shiny and yellow. The platinum has this dull gray silvery look, kind of almost like lead, but not quite. And but yet you can see how it might be confused for lead very easily. So it's important to look at it with a hand lens or magnifier and take a close look at the shapes and the crystals that you see in it, because that can give you some telltale hints to differentiate it from lead or from lead sulfide, galena, which is important in this whole mix, because platinum does tend to alloy with certain things and is found along with pyrites, similar to gold and chalcopyrites. Platinum versus gold in the pictures. You can see how it looks and the differences. Remember this. The platinum group metals. I'm going to talk about that. I mentioned it earlier in the periodic table. periodic table has platinum, rubidium, osmium, ruthenium, and we're missing one here. Well, we'll see it in a minute because it's on the table. And what does this mean? It means it's important to recognize the groupings of these other elements and how to identify them. So we have ruthenium, rhodium, the missing element, palladium, osmium, iridium, and platinum. Platinum has an atomic weight of 195.084. Okay, so you can tell as these things climb in their weight, they tend to be denser and denser as a metal. Now, also notice in these vertical columns, the chemistry of platinum is similar to palladium and similar to nickel. And so certain alloys can oftentimes be found, or certain elemental compositions can be found with substitutions of platinum atoms in place of palladium or in place of nickel. And so forth. You find the same kind of thing going on with gold and silver and copper. So that is where platinum sits on the periodic table, and it's important to recognize that for what we're going to follow through next. The platinum group is the red box. By the way, all 6 of those guys are extremely valuable. It really doesn't matter which one you find in what ratio. They're worth a fair amount of money per ounce. So, one of the things that I wanted to point out to you is the use of the USGS MRDS for global platinum location. I'm going to give a brief demo. I'll do that right now, and then we'll go back to the slideshow in a second. So let me swing over to Google Earth. I'll have to exit the slideshow and start it up again in a second. Okay, so, and now what we're looking at here, I drew some information from the USGS Mine Resources Data System, or the USGS MRDS. It's a free resource online. And then I used Google Earth to plot it and did some customization steps in addition to draw platinum mines as purple. For platinum purple. Okay. Now, the beauty of using this kind of system is you can easily locate different kinds of minerals. And it's talked about in my, I'll bring it up in a second, but anyway, you can locate the concentration of what type of mineral was found, because it'll show up with this little ticket when you click on that icon and tells you what kind of ore we're looking at for the Friday mine, for example. And there's chalcopyrite, magnetite, now remember that, pendelotite, pyrite, remember I talked about that earlier? Pyrrhotite, okay? And then some really nasty looking words like sinovolcanic, nickel, copper. Now, here's the deal. Volcanic is a word I'll bring up. Intrusive is another word I'll bring up later. What it really stands for is volcanic activity pushing through the crust in such a way that it embeds pyrite. That's the primary method you'll find pyrite. Now, there is some discussion, and I'll talk about it later, about other sources for pyrite. But in this case, we have copper, nickel, cobalt, and then we also have palladium, platinum, and iridium. When you see commodity 1, that's the primary producer of this mine. So it's primarily looking for copper and some nickel. But as a secondary or tertiary, as a third level, there is some palladium, platinum, and iridium being usually pulled out with the ore that has the copper in it. Remember I talked about how substitutes? So they can chemically reduce the platinum out along with palladium and iridium. All 3 of these are valuable, precious metals. Notice there's no gold here. Okay, so that's an